So, welcome to an introduction to congruent triangles. Now, congruent triangles, by definition, congruent, right, if you'll recall, even though it's been a while, does literally mean the same size and the same shape. So when we're talking about triangles, we're talking about two triangles that have the exact same size and the exact same shape. Now, same size has to do with the side lengths. So if we had a let's just say, for argument's sake, a 3, 4, 5 triangle, that would mean the other triangle that it would be congruent to would have to have the same side lengths, okay? Now, that would indicate the same size. Another way to think of that is it's a size transformation, dilation of scale factor 1, and that would work either way, obviously. So the other thing is, and this has to do with dilations, is that if we are looking at this, it means that the corresponding angles would also be the same in each of those triangles. Now, please notice I'm using different tick marks because each angle might not be congruent to itself, but I do know that this, the angle between 3 and 5, would have to be congruent to the angle between 3 and 5 in the other triangle. So the same shape has to do with the angle measures, okay? So there's a symbol that we use for congruent that's a combination of that, and that would mean congruent. It's an equal sign, and the equal, right? The equal has to do with the same size, as in equal measures, and then the similar has to do with the same shape. Now, in terms of the shape, we know that that's the angles, right, that are defining that. So that means that the angles are equal in measure, right? The angles themselves are congruent. And then the same size would mean is more of a reference to the fact that we're talking about the sides. And particularly, it means that there's a dilation of scale factor 1 happening. That is, if we do a scale factor 1 transformation, multiply everything by 1, it doesn't change, simply put, okay? So now, how to name congruent triangles. So what I'm going to do is I'm going to say that we have two triangles. We'll call one X, Y, Z, and the other P, Q, R, okay? And we're going to say that these two triangles are congruent. So what that means is, and I'm just going to kind of throw some markings here, that one side is congruent to the other, and this side is congruent to, let's say, this side, and then this side is congruent to this side. Now, this is where you have to be careful. When we look at the angles, if you look, there's an angle between the 1 and the 2 tick mark side, right? And it would have to be the same as the angle that's also between the 1 and 2 tick mark side here. What that means is angle Y is opposite the 3 tick mark, right, side, and angle R would be opposite the 3 tick mark side because they'd have to create the same angle. Remember, largest angle in a triangle is opposite the largest side, so we have to have everything match. But, conversely, smallest angle is opposite the shortest side. So that would mean, let's say we put the 2 tick mark angle here between tick marks 2 and 3 in terms of the sides. That would have to correspond to this, okay? And that means leaves the 3 tick mark. And the reason I'm using these different tick marks is I don't know that these angles are congruent to each other. I just know that from one triangle to the other, there are 6 pairs of congruent angles and sides. So we know that angle Y is congruent to angle R, right? Angle P is congruent to angle Z, angle Q. Angle Q is congruent to angle X. And we also know that side XY is congruent to side RQ, side YZ is congruent to the other 2 tick mark side. We'll call that PR. Remember, for these, it doesn't matter what order we do them in. And then last but not least, XZ is congruent to PQ. So that means these are the corresponding parts of these congruent triangles, and we know that they're congruent. 3 angles, 3 sides. How do we name them? Well, we would say that triangle is congruent to triangle Now, we can't just throw any 3 letters down here and call it good. because we do have to have these corresponding things match up. And here's how this works. You must pick one of the triangles to start with. I'm just going to pick this one. And I'm going to go alphabetical. I'm going to go X, Y, Z. Now, once I've set the order here, it sets the order over here. I can't just say R, Q, P, because it may not be the case that the corresponding angles and sides match up. So here's how we check. In order to do this, what we want to do is look at our thing and say, okay, angle X. Angle X is congruent to angle Q, right? The angle Q, which means that angle X is first, which means angle Q must be first, and because they correspond first to first, right? Angle Y is congruent to angle R, which means it must come second. Angle Z is congruent to angle P, so it must come last.
The boys' JV baseball team to meet their bus at the west end pool doors. Once again, please dismiss the boys' JV baseball team to meet their bus at the west end pool doors. Thank you.
And now the JV baseball team is off on its merry way. But the key thing here is this angle here in the first place must be the one that is congruent to the first angle here. So once you've set this order, the second order gets set. So X and Q, right? X is to Q, Y matches up with R, and then Z matches up with P. Now it also conveniently enough works out for sides. Sides X, Y, right? And side QR. Hey, look, XY is congruent to RQ, that is, these first two letters form a side, which means that these next two letters, YZ, also form a side, and then the next two letters RP form a side too, and those are the corresponding. So those are the other way you can tell. So what does this mean? If you change around the order of the first, like let's say you said ZXY, doesn't matter what order you do it in, you just then must set what this is. So once you've set this first one, well, we know that Z corresponds to P, so now P comes first, right? We know that X is congruent to Q, and then of course once you have these first two set, then that works out. And watch, side ZX is equal to side PQ. So when you're naming congruent triangles, you can pick any order you want for the first one, right? But that then decides what the order for the second so that the corresponding parts match up. So corresponding parts of congruent triangles, as mentioned before, simply means that there are three pairs of congruent angles and three pairs of congruent sides in any congruent triangle. And knowing what we know now, if I said that NOM was congruent to triangle, I don't know, how about AX, let's not use O again, right? That'd be a mistake. AXQ, right? Could you list off everything? Well, knowing what we know now, we know that angle N is one of the angles, angle O, angle M. What do they correspond to? Well, N is first, so it must correspond to angle A, and therefore we know that they're congruent. Same with angle O, it corresponds to X, the second letter, and then angle Q. So what are the three sides of NOM? Well, there's going to be NO, first two letters, OM, next two letters. And what's the last side? NOM, NOM, N to O, okay, O to M. The last two. So these two letters, first two letters, last two letters, and then the first and the last make up the corresponding sides. So that would mean AX, first two letters to first two letters, OM, second two letters to second two, so XQ, and then first and last, NM to AQ. So if you have a congruent statement like this, you can figure out exactly what's congruent to what, because we follow the same method for naming the triangles.